Okay, so number 17 says a Vermont study published in December of 2001 by the American Academy of Pediatrics examined parental influence on teenagers' decisions to smoke. A group of students who had never smoked were questioned about their parents' attitudes toward smoking. These students were questioned again 2 years later to see if they had started smoking. The researchers found that among 284 students who indicated that their parents disapproved of smoking, 54 had become established smokers. Among 41 students who initially said their parents were lenient about smoking, 11 became smokers. Wait, this is not the right problem. What did I copy? Okay, 11 became smokers. Do these data provide evidence that parental attitude influences teenagers' decisions about smoking? So we're going to let P hat D be the proportion of smokers with disapproving parents. And P hat L be the proportion of smokers with lenient parents. L-E-N-I-E-N-T. Okay, so you asked for C and D, the conditions, right? Who asked for this problem? If you asked for this problem, I hope you're paying attention. So C, are the assumptions and conditions met? Well, the teenagers with disapproving parents are independent of the teenagers with lenient parents. Was the sample random? A group of students who never were questioned. It doesn't tell us that it's random, right? So we're going to assume that each group is representative. That's the best we can do. And it's okay to say like both groups were randomly selected or both groups were randomly assigned to treatments. You don't necessarily have to write it in two separate sentences, but you have to talk about both groups. Okay? So both groups are representative. And the 284 is less than 10% of all teens with parents that disapprove of smoking. And 41 is less than 10% of all teens. I keep putting extra E's in the word teens. With lenient parents. And then NP, N1, P1, N1, Q1, right? So I have to do NP and NQ for both of them. For the smoking with disapproving parents, NP is what? How many successes were there? 54, right? So that's your NP. So 54 is greater than or equal to 10, and 284 minus 54 is 230 is greater than or equal to 10. That's NP1 and NQ1. And then 11 is greater than or equal to 10, barely, right? And 30 is greater than or equal to 10. That's your 41 minus 11. So since conditions are met, a normal model is appropriate. I will use a 2-proportion z-test. You can abbreviate to prop z-test. D asks, test the hypothesis and state your conclusion. So to test the hypothesis, p hat D is 54 out of 284, and p hat L is 11 out of 41. P hat pooled is 54 plus 11 out of 284 plus 41. So that's 65 out of 325. So we have to calculate p hat pooled for our standard error calculation, standard deviation for the z-score. So 65 out of 325 is 0.2. 54 out of 284 is 0.19. And 11 out of 41 is 0.26. Okay. Questions so far? P hat D is the proportion of students with disapproving parents, and P hat L is the proportion of students with lenient parents. So my z-score is, I didn't write hypotheses, so the hypotheses determine which way I'm going to subtract, right? So because I skipped B. So I'm going to go back here and write my hypotheses. P hat L minus P hat D is equal to 0. And my alternative is P hat L minus P hat D is greater than 0. Why did I choose to subtract the lenient minus the disapproving? Because lenient was a larger proportion. And I like positive numbers. Okay. Can I do it the other way? Sure. I'm going to get negative numbers. So because of that, my z-score is going to be P hat L minus P hat D over the square root of P hat pooled, Q hat pooled over NL plus P hat pooled, Q hat pooled over ND. So 0.26 minus 0.19, square root of 0.2, 0.8 over 41, plus 0.2 times 0.8 over 284. Questions? Do we need to go over how to put this in the calculator? We're just going to put it in. Okay, square root of 0.2 times 0.8 divided by 41 plus 0.2 times 0.8 divided by 284. I don't need parentheses around anything. The calculator is going to use the order of operations correctly for us. You might actually mess it up if you put parentheses in places that don't need it, you know? So we're going to hit enter, and that's the denominator, 0.0668. Nice and blurry. So, oops, 0.0668. Is that correct? Looks right. 0.07 divided by the answer gives me 1.047. Then we go to normal CDF to find our p-value. My alternative was greater than, right? And my z-score is positive, so 1.047, comma 99. So the answer, comma 99, is how I did it in my calculator. And remember that little rounding differences are okay. But don't round that to like 1. right? Don't even round that to 1.05. At least give me 3 numbers behind the decimal place when you round, okay? So 0.147, that's my p-value. I'm not multiplying by 2 because it's not a not equal to, right? So, what's my conclusion? Are we rejecting or failing to reject? It's greater than any acceptable alpha, right? 0.1 is the largest acceptable alpha, and 0.14 is larger than that. So we're going to fail to reject, no matter what our alpha was set at. Okay, and it's okay if you forgot to set an alpha. We go back to the top, and we go, okay, well, where are my hypotheses? Alpha equals 0.05. Boom. Okay, just go back and set it.
So for setting alpha, like in simple terms, you can put whatever you want.
If I wanted to put 4, 5, 9, 6, 2, 8, I could, but that's just silly, right? So it's usually 0.05, 0.01, or 0.1. Okay. Now sometimes on the AP exam it'll have you set one for 0.001 because the alpha level or the p-value is really, really small. But it'll tell you, use the significance level of this, or use an alpha of this. If it doesn't say that, you can use whichever one you want. And 0.05 is just the standard. So since my p-value of 0.147 is greater than my alpha of 0.05, I fail to reject the null hypothesis. And I want you to stop and think back to our cookie game. Okay? You rejected the hypothesis that that deck of cards was fair because there was enough evidence to convince you I was lying, right? So you rejected. You're like, no, this isn't a fair deck. Come on, show us the cards, right? Because there was enough evidence to say you're lying. So if I'm failing to reject, that means if I had used a fair deck, right, then people would have started getting cookies probably. Would there have been enough evidence for you to call me out on being a liar? No. There's not enough evidence, right, to convince you that it's false. So there is not enough evidence to convince me. And we're going to restate. Parental attitude influences teenagers' decisions about smoking. If this was an updated textbook, they'd talk about vaping instead, right? But this textbook's old. Vaping didn't exist in 2001. Okay. Create a 95% confidence interval for the proportion of children who may smoke and have approving parents and those who may smoke and have disapproving parents. Okay, so now we're going to create that confidence interval even though we rejected. It just wants you to practice that. So the difference in our calculation for confidence interval is going to be p hat L minus p hat D. Could you change it around? Sure. Your numbers are just going to be negative instead, right? Plus or minus your z star, and it's the square root of p hat L q hat L over NL plus p hat D q hat D over ND. So when you're doing the confidence interval, you use the actual proportions, not the pooled value, right? Because the pooled value assumes that they're the same. And we're saying when we're making a confidence interval, we want to know what that difference is. Okay, so this was 0.26 minus 0.19, 1.96. 0.26, comma 0.74 over 41 plus 0.19, 0.81 over 284. I designed this test to have lots of multiple choice questions that ask you about what's the proper way to plug it into the formulas. Because tomorrow I'll teach you how to use the shortcut. Okay? But you still have to know how everything goes into the formula and which one's right. And on a question like this about a confidence interval, I guarantee you one of the options is going to be this formula with the pooled value in it instead. Right? You have to know that for the confidence interval, we don't use the pooled proportion, we use the actual proportions. And you'll see an option on the z-score calculation that has the actual proportions, not the pooled proportions. So this was 0.07, right? Bring my square root of 0.26 times 0.74 divided by 41 plus 0.19 times 0.81 divided by 284. And this is 0.0724. So 0.07 plus 1.96 times my answer, 0.212. And subtract. Oops, it's the wrong boundary. Negative 0.345. These ones are hard to interpret. It goes from negative to positive. Zero's in my interval, right? Which supports our conclusion in the last problem, right? 0 is possible. Well, what does that mean? That means the difference is between 0.345 lower in the lenient group, because we subtracted lenient first. So if it's negative, that's 0.345 lower. Oh wait, this is not the right number. Hold on. I used answer again and that does not work. That's too big. This was too big. I used answer again in my calculator and then it used 0.212. This is 0.0718. Still negative though. So we're looking 0.0718 lower in the lenient group and 0.212 higher in the lenient group. Remember was p hat L minus p hat D. So if the answer is negative, if the subtraction is negative, that means the lenient group was smaller, right? So you had less smokers in the lenient group than the disapproving group for the negative. The positive would mean the lenient group was bigger. Jalen. The solutions didn't get this answer? Okay, so it's the difference, the reason the solutions was different is because I didn't round enough, or I rounded wrong, 0.064. And then when I do plus, I get 0.219 or 0.22. Yeah, rounding still.
So now what you were saying before, I'll just hop in.
Yes.
That sentence that you opened right there,
Mm-hmm.
I'm confused about it.
Okay, so this is how I did my subtraction, right? I did lenient minus disapproving, right? if this subtraction is negative, right, that means disapproving is bigger, right?
Yeah.
So that means the lenient is smaller. So the less smokers in the lenient group, right? And that's how much less, the negative number. So it's 0.6064 lower in the lenient group if I got a negative, right? And I'm not going to say the difference, like if I said the difference between the groups is negative, but I want to say which group it was higher or lower in. So I could say it's 0.064 lower in the lenient group, or I could say 0.064 higher in the disapproving group. And then the 0.22, that would mean the lenient group is higher to get a positive subtraction, right? A positive difference means the lenient group is higher. So when I want to write this down and talk about that before we interpret our interval, because we're going to include that as part of our interval. We see that we are 95% confident the lenient group of teens who started smoking, or the proportion of teens who started smoking in the lenient group, teens who started smoking, is between 0.064 lower and 0.22 higher than the teens in the disapproving group. Right? There's lots of ways we could say that, but that's what our interval means. We believe that it's between this much lower and this much higher than the lenient group is between 0.064 lower and 0.22 higher than the other group. And we have to really think about what that difference means and how we subtract it when we get one of those intervals that's negative and positive. My first instinct in 21 is that it doesn't meet conditions, right? Because there's only 7 live births of the...
In that instance, when it doesn't meet conditions, you just say like it does because it's pooled.
Right. If we look at the pooled and the pooled proportion would meet the conditions, it then allows us to continue. Right. So that's why that's all confusing, because we always try to find a way to keep going, right? Even if it says no. I know. Why did the book make you keep going? Okay. So in 1998, a San Diego reproductive clinic reported 42 live births to 157 women under the age of 38, but only 7 live births for 89 clients aged 38 and older. Is this strong evidence of a difference in the effectiveness of the clinic's methods for older women? Was this an experiment? No, they didn't like, hey, you're over 38. Can you get pregnant? Let's see what happens. Right? They're not randomly selecting people to get pregnant. They're looking at current pregnancies and following them for the 9 months to see what happens. So it's a prospective observational study. Test an appropriate hypothesis. So the hypothesis would be p hat less than 38 minus p hat greater than 38 equals 0. 10 years ago, I might have written p hat young and p hat old, but now I'm over 38, so 38's not old anymore. So, my jokes are falling on a few ears are hearing my jokes. Okay, so my alternative, p hat less than 38 minus p hat greater than 38, is a difference. Is there a strong evidence of a difference? So that's not equal to. Okay, that's the key in the question. Is there evidence of a difference in the two groups? It's not asking you, are they more efficient or are they more effective with the younger women, right? So the conditions, the women's pregnancies are independent of each other, whether they're, right? So women pregnancies under 38 are independent of those over 38. Okay, we can say that. 157 is less than 10% of women, pregnant women, under 38. And 89 is less than 10% of pregnant women over 38. Can we say it's random? No, not random. Assume representative. Both groups are representative of the clients. We're talking about people that are going to a reproductive clinic, right? That means people that were having trouble having a baby and now they're having a baby. Okay, we're not just talking about all pregnancies at a doctor's office. It's a specific place. Okay, so NP 7 is not greater than 10. But if we looked at p-hat pooled, (42) plus 7 over 157 plus 89. 49 over 346. Did I add right? $246. .199. So 246 times 0.199, right, is, oh, I know that. That's already 49. 49 is greater than or equal to 10. And shoot. $197. So pooled proportion checks. So since conditions are met, a normal model is appropriate. I will use the two-prop z-test. I'm not going to spend the time to write that down. So my z-score is going to be 42 over 157, which is 0.2675, and then 7 out of 40, or 89, 7 out of 89, 0.0787 over the square root of 0.199, 0.801 over 157 over 89. Right? So we're plugging that into the calculator. So 0.2675 minus 0.0787 divided by 0.05297 is 3.564. That's a large z-score, right? Wait, what problem am I doing? Oh, wait, I'm not looking at the right question. Huh. Okay. So then we do normal CDF. Do I need to keep going? Like, there's so many people having side conversations. I don't know why I can go in over homework if you don't need me to go over homework. 0.00182 is my p-value. I did normal CDF, 3.564, comma 99. So that's a really, really small p-value with this p-value this low. Okay, since my p-value of 0.000182 in the calculator, I got 1.82 times 10 to the negative 4. I like to. So since my p-value of 0.00182 is so low, so it's okay when it's really, really small to not reference an alpha because it's so small there is no alpha that would make you fail to reject. I reject the null hypothesis. There is enough evidence to convince me. And what does the question ask? There is a difference in the effectiveness of the clinic's methods for older women. And then if you concluded there was a difference, estimate that difference with a confidence interval and interpret that. So the problem there is we have to be really cautious with this confidence interval because success failure condition was not met. And we can say that, like, if you're on an AP test and it's doesn't seem like the confidence interval should be done because of the conditions, I would be very cautious. Make the confidence interval. Say conditions weren't met for this, so this interval we have to be very cautious about. And that way you have covered your bases.